Hey everyone, welcome to this Intro to React video. In this video, we're going to learn the fundamentals and core concepts of React like components, state, props, and hooks, as well as Tailwind CSS. And we'll put all of that knowledge together by building a task tracking app, which I know is super common, but for pretty good reason. These apps go over a lot of core concepts and common React functions that you're going to be using a lot of, especially when working on bigger apps, and you'll be able to build off of this when working on much larger projects. And just to give you a preview of what the project is going to look like, it's a task tracker. You're able to input some tasks like in React. You're going to be able to mark these tasks complete or incomplete. You can go ahead and edit these tasks if you want, and you'll also be able to delete tasks. And although this is a React beginner's course, I recommend having fundamental knowledge of HTML, CSS, and JavaScript before diving into React. You don't need to be an expert, but having that foundational knowledge will make things much easier to understand. So without further ado, let's get your dev environment set up so that you can start coding. All right, to get set up, you're going to need Node. And if you don't have that already, you can get it downloaded and installed on their website at nodejs.org. And just go ahead and click Get Node and just use the LTS version and whatever platform or operating system you're working on. Go ahead and get it installed. And once you have done that, open up your code editor. In this case, I'm going to be using VS Code. To check that you have Node installed properly, you can just do node-v into your console, and it should say the version that you're working on. Now, go into the folder that you want this app to be created in, and you can either CD into it, or in this case, you can actually just drop it into your VS Code console like this. So once you're in there, you're going to need to install React by running the following command. In this case, we're going to be using Vite. So to do that, we'll do npm create Vite at latest. Go ahead and name your project. I'm just going to call it my task tracker. Go ahead and choose React, and we'll just use JavaScript. It'll prompt you to CD into your folder. We'll go ahead and do that. My task tracker. And then run npm install. It'll install all of the packages for the project. And then after it's done installing, just run the command npm run dev, like it says here. Npm run dev. Awesome. So once that's done, something like this will show up. You can just copy and paste this into your browser, or you can just control click and go right into the app. So this is just boilerplate code that it has set up for Vite. But you basically have React up and running now on your computer. And now, before we get any further with actually touching any of this code, I do want to talk about extensions real quick. This isn't super necessary, but it does help making write code much smoother. To do that, go into VS Code and click this right here. These are some of the extensions that I use, one of them being Prettier. So you can just search up Prettier. This basically just helps automatically format your code so that it's consistent every time you save a file. So another thing that I recommend using is ESLint, which is essentially just a spell checker, but for JavaScript and React. It'll help scan your code for any potential errors and give you hints or warnings before you run your code. So super useful when it comes to just catching bugs or errors with your code. And one other thing is ES7 plus React. You can just search this and go ahead and download this extension. So this is probably the least important of the three. It's more so just for productivity boosting. What this does is it essentially just provides code snippets for very repetitive code and will save you a lot of time typing the same boilerplate over and over. So not super necessary, but it is kind of useful. So again, these extensions aren't super necessary for writing code, but it does kind of increase the quality of life when it comes to writing code. So with that out of the way, let's go ahead and actually start getting into this app. So actually, before we start writing code, it's probably better to understand the structure of our project first. So go into your file viewer here or file explorer here, and you could take a look at what the file structure looks like. So At the top here, we have our node modules, which basically is just all of our dependencies, or where all of our dependencies are stored. It can look kind of intimidating because of all of these files here, but for now, you can just kind of ignore it. It essentially is just all of the libraries and tools that our app needs. And we also have our public folder, which basically just holds our static files. So if you want to include images or icons, you just put them in here. You have our source folder, which is going to be the folder that we're going to be spending most of our time in. It'll have all of our React components, styles, and other code. Then we have our app.jsx folder. This is going to be the main React component that our project is going to be in. It's essentially the homepage component that all of our other components plug into. Don't worry if this sounds a bit confusing right now. We're going to dive a bit more into this as we start working on our project. Then we have our app.css and index.css files. So these are essentially our CSS files. The app.css, it ties into the app component and basically is used for layout or styles that directly uses app.jsx. And our index.css is for basically global styles like typography and variables and such. Our main.jsx file is what connects our React app into the web page. Basically, it tells React to render the app component inside the index.html file, which we'll touch on in just a bit here. We're not going to be working in this file that much, but it is good to know what it does. And for the index.html file, this is the HTML file that our React essentially renders into. If you're coming from HTML, CSS, JavaScript, this is going to look very familiar to you. But the one thing to really keep in mind here is the div right here where it says ID of root. This is essentially where React will mount and get injected into our app. Basically, when we go back into our main.jsx, it'll say here, create root document.get element by ID root. And essentially, it takes all of our JSX and injects it into this root div, essentially. And then we have our patches.json, which essentially keeps track of all of our project settings and dependencies. Don't have to worry about this too much. Just basically, it's kind of the settings for our app. And then same with vite.config.js. Basically, you're not going to have to worry about this too much, but this is a configuration file for our project. But with that out of the way, we're actually able to get right into the coding process and dive right into React. So the first concept we'll get into is components. Components in React are essentially the building blocks of an application. Instead of having to write all of your HTML into one big file, React lets you split your UI into smaller, more reusable pieces called components. You can kind of think of components as like Lego blocks where each block or component can be built, reused, and combined to make a much bigger structure. So I think to illustrate this, it's good to just dive right into the code here and take a look and see what it looks like in action. So go ahead and get into your app.jsx folder, and we'll go ahead and clear out all of this starter code that they have included for us. We'll also close out the index.css and app.css. So we're going to start with a blank slate here. And inside, all right, let's go ahead and pull up this browser to see what it looks like. Get it side by side here. So go ahead and inside this return block, you can just type a simple hello world. You can see that it's rendered right over here. So in this example, we just returned the hello world statement. We didn't really write a component here, but to write a component, you'll need to write a function like this. It can be just a regular function or an arrow function, but in this case, it would be like this. Now, to use this component inside of another component, we just included like a custom HTML tag. So go ahead and do this. And you notice that the hello world still is rendered. We're essentially importing this component into here, and it's being rendered inside our app function. Now, suppose you wanted to do a little more with this. You wanted to add some additional text like this. You'll see that ESLint is going off already, but if you hit save, you'll actually run into an error. And that's because React components need to return a single parent element, meaning it needs to be wrapped in a div or section like this. So that's just something to be aware of when you're building components in React. There are some other rules to keep in mind when creating components in React. One thing is that you want to use capital letters when naming a component. The other, as mentioned before, you want to wrap it in something. It could be a div, it can be a section, but the idea is you do need to keep it wrapped when you're creating a component. And another is to not nest components. And what I mean by that is you don't want to create your welcome function like this. You don't want to put it inside of your app component. And even though this technically did work, it's not really advisable. It can lead to issues down the line, and it can lead to performance issues as well. So it's better to just keep it separate and not nest these components. So as you can see here, we're essentially just writing HTML. And the reason we're able to do that is because of JSX that's in this file. JSX essentially stands for JavaScript XML, and that's how we're able to write this HTML-like code inside our JavaScript files. And basically what React is doing is it uses JSX to describe what the UI should look like. You can think of JSX as a bit of a shortcut for us. So that's pretty cool. One thing to keep in mind is there are slightly different syntaxes or naming conventions. For example, in JSX, instead of class, we use class name to define our classes. And something else to be aware of with JSX is that it uses camel case for its attributes, meaning instead of just on click like this in JavaScript, it's on click with a capital C or tab index with a capital I. So that's just something else to be aware of. So now that we've gone over some of the differences between HTML and JSX, we're going to go into components and how to import them. So far, the code we've written have all been in the same file, and that's fine when we're experimenting and working on small scale projects like this. But as your app grows, it gets very messy if you just write all of your code inside this app component. So something we could do is to actually import these components and store them in a separate file. So the convention that you use is going to vary depending on preference and the project or code base you're working with. But typically what I like to do is just go into this source folder and create a components file and put that in there. So in this case, we can just put maybe a header, or we could put our little welcome section in here like this. We'll go ahead and take all of our code in here and put that into here. Make sure to export default when we are looking to export our components. This basically lets React know that if another file wants to use this welcome component, it can be imported. And to import it, we'll have to go into here. If we actually hit save, it's going to give us an error and it's not going to show up because we haven't imported it yet. So to import it, we'll have to go and type this. And there you go. Now, up until this point, we've really only been building static components, which don't really offer much customization. For example, this welcome component is just going to read the same message over and over. And to really drive the point home, I'm going to create another component here. And I'm going to go ahead and render this greeting into my app component. Make sure to wrap this in a div, by the way. So to make this greeting component more flexible, we can indicate that it's accepting props essentially by doing this. And I'll go and explain the syntax in just a bit here, but I'm just going to go and create this example for you to take a look at. But basically what this is telling React is this component is going to accept props, and the prop that we're going to pass to it is a name prop. So we go ahead and define that in this component here. But basically this lets React know that it's accepting a prop, and by defining it, it's accessing this prop or property called name. And as you can see here, it's being rendered in our app, the name prop that we're passing down to it. So as you may have noticed, we wrap this in a curly brace. Basically in React, curly braces are used to escape back into JavaScript, and we're able to evaluate JavaScript expressions within these curly braces. You can kind of think of these curly braces as a doorway back into JavaScript. Like I was saying, you could really put any sort of JavaScript expression like variables in this case, or math and even function calls within these curly braces. In the example above, the name is accessed by props.name because props is the object that is being passed into this component. Now, this method of rendering props is completely fine, but having to constantly write props.something can be a bit repetitive. So an alternative way of doing things is by destructuring the props inside the parameter by doing this. So instead of writing props, you can just destructure it. And so you don't have to write props every single time. And this will give you the exact same result. And with props, you're actually not limited just to a single piece of data. And to really illustrate this, I'm going to create a user card component that is able to accept a name, email, and phone number. I'll go ahead and build it right now. I'm just going to use some inline styles as well for this. We'll worry about styling this and making this look nice later. Now, as you can see here, each user card displays different user information, essentially all powered by props. So pretty cool, right? However, in the real world, you're not going to know exactly how many times you're going to render something, whether it's a to-do app or a name card like this, or just a post in a blog. Your data is usually coming from a database or an API. That means that it's going to be very difficult to hard code each component with data like this. Instead, you're going to have to map over it. And I'll go over exactly how that's done here. So instead of working with data that you're inputting in, piece by piece like this, you're going to be working with something similar to how this looks. I'm going to go ahead and copy and paste over an array of objects like this. So usually you're going to get an array of objects, typically when you're working with a database, similar to something like this, where you're going to get the name, email, and phone as a key. Now, what you could do is take each user, just map over it, and pass them into the user card like this. So remember, to get into JavaScript, we're going to have to use the curly braces, and what we'll do is we'll take this users variable and map over it, and we'll take each user and we'll essentially return a user card for each of these users and pass in the name, so as you can see, we use the .map method to loop over the array and map it onto the user card. However, there's something I also wanted to show you real quickly. If you open up the developer console, you'll see that we have a bit of an error here. Well, a couple of errors actually. One click. Okay, so it looks like I forgot to close this out, but anyways, the real issue that I wanted to show you was that we're getting this error saying each child in the list should have a unique key prop. And the reason for that is because in React, we want to input a key in our when we're mapping over stuff, essentially. So when we render a list of components using the .map method in React, React needs a way to identify each component uniquely. And this is important for performance and for correctness. If a component is added, removed, or changed, React needs to use this key as a way to decide which component to update in the DOM. So to address this, it's pretty simple actually. We just need to include a key prop like this. So in our user card, we can just go ahead and type key equals user.id. So something to keep in mind when we're using a key, we need to use something that is unique, and most databases will have some sort of unique identifier for their objects. Typically, it is just an ID. Obviously, most of the time it'll be a little more complex. They're not just going to use 1, 2, 3. It'll usually be a longer string of numbers to identify it with. But to address this issue, you just have to input a key like this, and it should fix our errors once we save. And there you go, no more error. So far though, we've just been rendering all of our data, but what if we want to conditionally render something? For example, we only want to render a particular amount of cards, or maybe in our application, we want to render a login button if the user's not logged in, or if we're working on a task list, to only render tasks that are in progress or tasks that have been completed. So the idea of showing different things depending on a condition is called conditional rendering. But to demonstrate what I'm talking about, I'm going to go and use this tasks app, or use some task data to demonstrate this. I'll go ahead and clear up some of the code we have here. All right, so given this array of tasks, what if we just wanted to render tasks that are complete? So there's a couple ways to go about this. We can go and just filter this list and then map over it like this. So again, we're going to use these curly braces and go into our tasks array and filter by completed items. And to do that, we'll just look at each item or each task and check to see if it is complete. If it is, we'll put it into this new array, and then we'll map over it. And let's just map it as and of course we're gonna have to put an ID. Cool. Now, another method is by using a ternary operator. So essentially, we could take a condition, and we're checking to see if it's true or not. If it's true, then we'll return this first expression. If it's false, then we'll return the second expression. So basically, we're going to check a condition. If it's true, we'll return this. If not, we'll return this. So you can think of it as essentially an if-else statement, but in a more concise way. So applying this logic to our same list, we can do tasks.map. We take each task and we check if task.isComplete is true. If it is, we're going to return if it's true, we'll return this task. If not, we'll just return null. And you'll, oh, gotta delete this. And yeah, you'll see that we have essentially accomplished the same thing here. So what we could also use instead is the logical AND operator, which is the double ampersand sign. And to illustrate it, I'll go and use the same example with our tasks list. So we can go ahead and take our tasks and I'll just go and copy and paste this. But basically what's happening here is in React, it checks if the left side of this statement is true, and if it is, it will render the right side. So if isComplete is true, it'll render the task name. And you'll see that we've essentially achieved the same result with this code. So something to keep in mind is that this method works because isComplete is a Boolean value. If we change this isComplete from false to just say a string or anything, then technically this will actually evaluate to true, in which case you do see this task show up. So that's just something to keep in mind here. This logical AND operator essentially just checks to see if this left side is truthy, and if it is, then it will render what's on the right side here. So that's just something to keep in mind here. All right, so now I think is as good of a time as any to get us introduced to Tailwind CSS. And Tailwind CSS is essentially a utility-first CSS framework, and it's a very popular framework that developers use for styling. But ultimately, it's completely up to you what you want to use, whether it's Bootstrap, Sass, or just traditional CSS. So you don't necessarily have to follow along with this or implement Tailwind CSS, but personally, it's just something I really like to use because it offers a lot of flexibility and just helps with the efficiency when it comes to developing and styling my projects. But yeah, just to touch on why I use Tailwind CSS, I just mentioned it, but basically the speed of development, and also I would say consistency. With Tailwind CSS, you're able to use their design system, and so your project is able to stay very consistent when it comes to spacing, colors, and typography. Another is customization. So Tailwind can be extended to match your project's brand with custom colors, fonts, and themes. And I would say my personal favorite is not having to worry about naming components or coming up with unique class names for these components. For example, if you're building different types of buttons, you'll need to create a class for like a primary button, button dash primary, or button dash cancel, or button dash submit. It just makes things a lot smoother and is very good for the development process, in my opinion. So let's get into setting it up. We could just go ahead and follow along in their docs. They do a very good job of explaining what to do. But yeah, to get it set up, go into your console, and we already created the Vite project. So we just go ahead and copy this into our terminal. And the next thing we want to do is go into our vite.config.ts file and be sure to import it and type this in there. Now we need to go into our CSS file and import Tailwind CSS. I would recommend going into your index.css file. And I think that should do it. You'll notice that the style did indeed change. So it looks like Tailwind CSS was set up. I'll go ahead and delete this. So what it does is they actually just have a bit of a style reset for you. That's why our h1 tags and going to have its own, like, I guess, base style. All right, so with, I guess, typical HTML and CSS, you would just do something like this. You would have to define a class name for a particular button like this. All right, so that's how you would do it with just regular CSS. But with Tailwind CSS, instead of having to define the class and go into your CSS file, you can define it inline like this. So essentially, each class represents a single piece of styling. So this BG-blue-500 indicates the background color of it. It's a little different. We're using the design system of Tailwind CSS, and Tailwind does a really good job actually of documenting this. So you can go into background color, and it's going to have, it'll have all of the different colors. You can look this up yourself, but basically with Tailwind CSS, a lower number like 100 would mean a lighter shade, whereas a higher number would recommend a darker shade. Personally, I find that their color palette is a little more modern. So if I used a different color like slate, but yeah, I just find their colors a lot more modern. And some of the other more common features that you're going to use Tailwind CSS for is maybe their spacing, which is defined here, px, py, which px, that defines the horizontal spacing, so along the x-axis, whereas the py defines the vertical padding. So we can change this to increase the vertical padding, py-4, and you'll see that it's got more vertical padding there. And furthermore, with typography, you could define the text size with things like text large, and you'll see that it's bigger. You can use text 2XL, and something like font to get the font weight. So font, maybe bold. Now, this might seem maybe a little convoluted at the beginning, especially when you're defining a lot of styles in line, but once you get the hang of it, it actually is very smooth and very easy to work with. And, early on, I'd say maybe the most time-consuming part of it is learning all of the different class names and knowing which ones translate over. It is pretty intuitive, though. For example, like BG-slate, you know that you're working with background, and then with text color, you just do text-white or text-blue-200. But yeah, some of it's pretty intuitive. The main thing early on is being able to figure it out. But Tailwind CSS does have very good documentation in that regard. You can always just look up the particular class property that you're looking up. So, for example, if you needed something like padding, it'll do a really good job of breaking down what does what, or what each class name represents. Something else you're probably going to use a lot of is flexbox layout, and this helps a lot. So with flexbox layout, you want to use the class name flex to indicate flex, and then gap to do the spacing for it. And if you wanted to change it to columns, you could just do flex column. See that it's changed and it's taken up the width of the screen here. And something else that's really cool with Tailwind CSS is that it's got some built-in media queries. It's got breakpoints built in, essentially like this. I'll go ahead and give you an example real quick. So with this resize, so we'll go ahead and try to resize this text depending on the size of the screen. So we're going to see that as we change the size of the screen, the text will change sizes. So essentially what's happening here is we're defining a breakpoint of medium, which means at 768 pixels, the size of the text will change to text large. And then when it gets to the large breakpoint, which is 124 or 1024 pixels, the text will get to text 3XL. So that's what it does when you're defining these breakpoints in Tailwind CSS. It's also got some pretty cool hover and state variants that you could input into the class name. So for example, using our button again, we want to change the color with a hover. So hover And in terms of customization with Tailwind CSS, even though their built-in styles and sizes are very handy, sometimes you just need something that is a little bigger. So what you could do is, when it comes to width, you can do like something like W-200 pixels. Just use these brackets to define the actual size that you want your component to be in. And this works for colors as well. Basically anything that you need some custom sizes for. So instead of just using this color, we can use these brackets and then define the color that we want to use. So this is just a very useful feature when it comes to Tailwind CSS. And there's a lot more to use Tailwind CSS for, but this should cover a lot of the more general usages for it. I would say the most time-consuming part early on is really just getting familiar with the class name and their naming conventions. But once you got that down, being able to style your apps should be a very quick and smooth process. But moving right along, we're going to get into, my opinion, the most useful part of React, which is state management and events. So essentially with React, up until this point, we've been building pretty static components. We've kind of just hard-coded data, and even though we've been able to conditionally render stuff, we're not able to really interact with any of the components we've built so far. But in real apps, obviously, we're going to need components that can change over time, basically to respond to user input and stuff like that. So to do that, we usually have to work with state. And basically, what state is in React is essentially it's memory for that component, right? It's data that belongs to a component and can change over time. So for example, with a to-do list or an item, we can mark it as complete or not complete. And when state changes, React will automatically re-render the component to reflect the new value. And I think with anything, the best thing to do is to probably just use an example to illustrate this. So I think one of the most common examples when it comes to state is by using a counter. It's something you'll see a lot of, and I think it does a good job of introducing some of the basics of state. So with state, it is something you'll have to import with React. It's essentially a hook that React provides. It's one of those special functions that is built into React, and to import it into your project, you'll have to do this. Now, to initiate state, we'll have to do something like this. So what's happening here is when we're creating state, we've done two things. One is declare the count and also set count. Basically, count represents the current value of count, which is 0 is what we initialized it with, and set count is a special function, a setter function used to update the value. Right now, when we're just starting out and initializing state, use state 0, lets React know that the starting value is going to be 0. And right now, we're not going to add too much functionality to it. We're just going to go ahead and render state. Remember, state is held, or at least this count, it's held in this count variable. And to do that, we'll again have to use curly braces. You'll see that we have a 0 here. I'll go and make this bold. Now, to make changes on count based off of user input, we're going to have to listen to events. And events are essentially how we respond to user actions like clicks or typing on form subscriptions and stuff. So in React, you want to attach event handlers directly to the JSX using camel case like onClick, onChange, or onSubmit to listen to these user events. So putting it all together in how state and events work together, we essentially declare state here and we display it in JSX. It's rendered on our screen here. And then we're going to have to attach some sort of event handler like onClick to update the state, and then React re-renders and it will show the new state here. So to add a bit of functionality to our app here, we're going to create a function that will handle an increase in count. We'll call it So what we've done essentially is create a handle increment function, which takes the count and increases it by 1. And something worth noting is that we don't want to access state directly. We want to use the setter function to alter state. Now we need to implement a button that will actually call this function when we click on it. And there you go. So a few things to be aware of when it comes to state is that one, state updates are asynchronous, meaning when we call the state updater function, in this case set count, React doesn't actually change the state immediately. It schedules an update, which means you can't rely on the state changing instantly within the same function call. And I think a good way to illustrate this is by doing a console log inside this handle increment statement. And we're going to go and see what happens when we update the count. So right now our count is at 7. We'll open our console log. So if we increase the count, we notice that even though in here it's supposed to have incremented the count, we still get a log of 7. And something else worth mentioning is that state is local to the component that it's in. So basically each component manages its own state. And I think to illustrate that, we'll create a separate component just for this counting function. So we'll see that as I increase the count here, it's not going to mess with the count in this other component. So basically, the state is confined to the component that it's in. If you want multiple components to have the same data, you'll need to lift that state up, which is something we'll touch on a little later. Now we're going to go over another very commonly used hook in React, and that's useEffect, which is essentially used to handle side effects. And what that is, or what a side effect really is it's something that your code does that is outside of its own scope. So something that is happening outside of React. Typically, it's going to be with data fetching or setting up event listeners. And one way to really look at it is if you're doing something outside of React, you'll need to use useEffect. And to set it up, you'll need to import useEffect. So it's do this. And this is the syntax you'll use when setting up useEffect. And with useEffect, it actually takes two arguments. The first being the code that you want to run, which is, leave it blank for now, and then a dependency array. And to illustrate why useEffect might be used, I'll go ahead and fetch some jokes from a joke API. First, I'll go and initiate state. So I accidentally hit save here, and you actually see the issue that you run into when you're not using useEffect. Essentially, what had happened was I ran into an error. I'm going to have to comment this out and save it, actually. So the reason I started running into all of these errors here is because I had made an API call to this API endpoint. I was able to get a joke, and then I set it in state. But what's happening here is essentially React renders the component, the fetch runs, and then the data gets set in state. Updating state causes the component to re-render, and when it re-renders, it runs the fetch function again and essentially sets the joke again, which causes another re-render, and fetch app runs again. And so basically what's happening is we're kind of stuck in this endless loop of re-rendering and fetching this API, setting joke, and then re-rendering, and on and on and on. And essentially what had happened here was the API I'm using kind of just limits me to 100 calls per 15 minutes. And after that, they're going to block me from continuing to make API calls and flooding the servers. So that's why we're getting this error. And yeah, we're going to get timed out for 15 minutes here, essentially. But in order to fix this, we're going to have to actually put this into the useEffect. I'm going to take this, uncomment it, and put it inside our function call here. So with useEffect, essentially the code in here is what React is going to run, and then this dependency array, this empty bracket right here, is basically telling useEffect when the effect should run. So if the array is empty like it is right now, the effect will only run once. And if we put some sort of value in here, it'll only update when the value changes. And to illustrate that, I think we could use some other example while I wait for my timeout to expire. Yeah, I'm still timed out. So I'm going to go ahead and use the same counter app that we've used before as an example. So essentially what's going on here is we've created state for count and our message, and to also create a useEffect, which uses count, in this case in the dependency array. So it's telling useEffect to refer to the count value, and whenever it changes, we'll run this useEffect. So basically when we go in here and we click on handle increment, or we click on this button to handle increment, it will increase the count, and useEffect will notice that count has changed, and it will update the message to you click the count however many times you clicked it. So just to quickly wrap up, useEffect is a hook that React provides for handling side effects, which are basically just operations that happen outside of the normal rendering process, like data fetching or subscribing to events. And this dependency array basically just tells React what to look at and when to run this function inside here. This dependency array essentially controls when the effect is run. So if it's empty, it basically just runs on mount, and if it has a value inside of it, it'll run when this value changes. And basically using useEffect really just helps prevent issues like infinite loops and make sure that your component behaves predictably when you're working with asynchronous data or external resources. All right, so now that we've gone over the fundamentals of React, I think we can move into just the actual build of our project, which is to create our task tracking app. And I'm going to go and write down a list of the objectives that we want to accomplish with this task list and put it into our README file here. So I'm going to go and delete this stuff here that is okay. So when it comes to the main functionality of our app, we want to be able to write tasks, add that to a list, and then be able to edit and delete these tasks, right? Okay, so I'm going to go and clear everything out that we've been working on before and start with a bit of a clean slate. So the first thing we want to be able to do is write a task into an input field and basically create this task. So in order to do that, the first thing we'll want to do is set up an input field, and we'll need to create state for that, some way to hold this value of this task or task name that we want to input. All right, so now that we've set up state, we're going to need some sort of function that can handle the input change. So we'll go and create a function here. Now we're going to actually render the form input, or the input for the user to type the task name into. So we'll just use a form element. So the reason we're using this class name SR only is to basically only have this label for screen readers only. It's actually not going to show up for users that don't need it, but it's just there for accessibility purposes. So I'm going to go and center this. All right, cool. So essentially what we've done so far is just we've created this input box, we've styled it, and we've hooked up the onChange function to this input so that it is able to update state as we type into here. And we basically turn this into a controlled component by making sure that the value of this input box is going to be the same as what's held in state here. And that's why the value is going to be equal to the task name. Now we need to just create a button that we can click so that when we click on it, we'll be able to add this task to our task list. Awesome. As of right now, we don't have any functionality in our button just yet, but we'll go and add that in just a bit. Okay, so now the next thing we want to do is actually be able to add this task into a task list. And as you may have noticed, we don't have state for this list just yet, so let's go ahead and create that. And since these tasks are essentially going to be an array of objects, we want to initialize an empty array right here. And now that we've created state for this task list, we actually need to create a function to add this task to our task list array. And remember, we want to prevent default here so that the page doesn't refresh when we hit this button. Now, something to think about as we're creating this task is what we actually want in this task object. So remember, when we're rendering these tasks and mapping over them, we're going to want some sort of unique identifier. So for this task, we want to have an ID. We're obviously going to want to have the task name. And I think thinking a little further ahead, we also want another key to indicate whether this task is completed or not. So maybe a variable is complete inside of this object. So in order to do that, we want to create a new task and then push it or set it into our task list. So let's define a new variable here called new task. And there's a few different ways you could go about creating an ID, but there's actually a pretty cool built-in method in JavaScript that we can use, which is crypto.randomuuid. So we can just define this ID property, crypto.randomuuid. And you won't have to install any libraries for this, which is pretty awesome. And then we'll call the name of this task task name. And what we actually want to do is we'll trim it so that if the user inputs like space, blah, 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 space, we'll just trim this white space on it just for UI purposes, make it look nicer. And then we'll initiate it so that when we create this task, by default, it will be false. Now what we want to do is we want to use set task list and push this new task into our task list array. So essentially what we're doing here is we're spreading this old task. We're taking the previous task list and putting everything in there and then adding this new task when we're setting this new task list. And then we'll just go ahead and hook this up into our button. Or actually we can put this into the form, right? Because we're submitting it technically. And we could go ahead and console log the task list just to test it real quick. Right now it's empty, which makes sense. And yeah, we'll see that we have an ID created for this, the name of it, and is complete is set to false. And something I did notice here is that this is still inside the input. So what we want to do is after we hit submit, we want to set the task name. We want to reset it essentially and change it back into an empty string. Close this. Okay, cool. So it's working now. So it's working as we expect. All right, so now that we've got all of the functionality set up for creating a task, we need to actually render this task list. And typically what I like to do is I just like building the UI for it first and then mapping over it. I just like having that visual cue as I'm building it. So we'll go ahead and do that. This will be the main container for our task item. So this will be the task name. I'm just going to use some filler information. Okay. And what we want is to be able to create a checkbox on the side, right? All right, then I think we could import a checkbox icon, but what we could do is just use Unicode for it, in which case, let me pull it over. Now you can use a library for this. You don't have to use Unicode, but I think for simplicity, we'll just use it. Okay, awesome. Okay, cool. Now I think I want to create a little divider here, right? So what we can do is just use and now we want to create the container to edit and delete the, or to hold the edit and delete buttons for this task item. Okay, cool. So it looks like we've built the container for this task item. Next thing we want to do is just actually render it. And so we go into our task list, and what we'll do is dot map it. Take each task, map over it, and we'll return something like this. And this task name, we'll just change it. Oh, right, we need to create a key for it, which is... So something we could do to actually clean this up a little bit is to refactor a little bit of this and create a component specifically for this task item. So what I'll do is actually define another function. And remember, we're taking the task as a prop. Awesome. Cool. So we've essentially just rendered and built it, but we still need to actually add functionality to this task list. So the first thing I guess we could do is implement this toggle task function, which is to make it so that we want this task to basically be marked as complete or incomplete and have some sort of UI that could reflect that. So the first thing I actually want to do is create a toggle function. I'm going to close out of this. And for this toggle complete function, we actually need to take an argument. We need some way to know which task it is that we're changing or toggling. So one way we could identify it is with the ID identifier. So we can pass in the ID as the argument. And then inside of this toggle complete function, we want to basically update state and find the task item with this matching ID and change is complete to the opposite of whatever it is that is existing. So to do that, we'll need to set task list, and we'll take all of the previous items and we'll map over it actually. Okay, so essentially what's happening here is we're calling task complete, which takes all of the previous list essentially, and it maps over it. And for each task on the list, we're checking to see if the ID of that task is equal to the ID that we've passed in. And if it is, we're going to take is complete and get the opposite of it. And if not, we're just going to return the task. Now we just need to hook this up onto the actual button, which is this checkmark button right here. So we need to pass an onClick on here, which is, I believe, toggle complete, right? Toggle complete. And we need to make sure it's accepted as a prop. So before it was is complete is false, and it's still false. So something is wrong here, right? Okay, so something is still wrong here, and okay, yeah, we shouldn't actually pass in the function. We need to actually put in the ID of the ID of this task as the argument, remember? So now what we need to do is implement some sort of visual cue. So even though it's updated in state, you're still not able to see it in the UI. So to be able to implement this visual cue, I think is going to be a pretty straightforward. So we're going to have to use some ternaries in here. Okay, so what we're actually going to need to do is we're going to, since we're going to dynamically render UI, we're going to need to use some curly braces to define our class name. So I'll go and delete this and wrap it in curly braces. Now it's showing an error because class names, it needs to be string essentially. So we're going to wrap this in template literals. And what we're going to do is we're going to check and see if the task is complete. So we're going to go back and try and do JavaScript in here. We're going to need to evaluate some logic. So is task dot is complete. Now, if it is, what we're going to do is we're going to render this stuff in here, and then if it's not complete, we'll render this. So basically, if it's incomplete, we want to put all of this text in here, and if it's complete, we'll use a blue border, blue dash 500. Cool. And something I also want to do is maybe update the text of this of the task name so that we have the strike through effect. So if it's complete, we're not going to change it. But if it is not complete, or actually it's the other way around. If it is complete, we want a strike through. It's too dark. It's too light. Cool. All right, cool. Now the next thing I want to do is be able to delete and update a task. So we'll work on deleting a task first because it's a bit simpler than updating a task. So to delete a task, what we need to do is we need to create a delete function. And similar to our toggle complete, we're going to need to take an ID as an argument so that we're able to identify which task it is that we want to delete. We'll take the previous list. And what we'll do is we'll filter through it actually. So what we want to do is we actually want to look at the previous list, and then if the task is not equal to it, then we'll so we're basically filtering all of the previous tasks whose ID does not equal the ID that we've passed in. So essentially, this is what we'll do. And why we're using not equals instead of equals to is because if it's set to equals to, then the list will get updated so that it will only return the task that we're deleting, which is the opposite of what we want. Now we just hook that up into our button. Awesome. All right, now next is to edit a task, which is going to be a little more tricky because in order to edit a task, we're going to need to dynamically render an input field that is going to show up when it's being edited, and then also have to update that. We need some way to store what the value of the task is, essentially. So there's a few things we could do to do this, but I think the approach is to put state inside this task item, and this state will essentially hold the value of whether or not the user is editing and the value of the input, essentially. So we'll go and create that inside our task item. And by default, they're not going to be editing, right? So we'll set it as false, and then we'll set the edited task name. And we're actually going to initialize this so that it's the name of the task that's being rendered. That way, when the user clicks into it, it's going to show the name of the task and not just an empty input. It's just better for user experience, in my opinion. Okay, so next thing we want to do is hook up some functionality to our edit button so that when we do click, forgot to change this, but yeah, we're going to create some functionality on click, and by clicking it, we're going to change set is editing to true. Okay, now we want to create the UI for the edit task name input field, right? Because right now it's not doing anything. Okay. So something I like to do is I just like building out the UI first, and then we'll go and put in the conditional logic and stuff. Now I'm going to create the divider, which I can just use the same one from up here. Divider. Then I'm going to add the save and cancel buttons. And for this cancel button, what we want to do is actually just make it so that when we click cancel, we're just closing out of this edit. Oh, okay. So now that we have this editing box set up, we only want to conditionally render it if is_editing is true. So we'll wrap all of this in curly braces. So we want to check if it is editing. If it is editing, we're going to put all of this code in here. And if it's not editing, then we just want to show the actual task. So, okay, so we need to update the value of this task input so that it is reflective of this edited task. So it gave us a bit of an error here. That's because we don't have an on-change handler for this, which we're going to implement right now. Okay, no more issues. Okay, now we need some way to actually save this value into our list. And remember what I was talking before about state being separate. So basically what's being saved in here, or the task name that's being saved in here, is not, we can't define this function to update the task list inside of this task item. We're going to need to define the function to actually update this task list in this app component here, in the parent component essentially. So long story short, this parent component basically can't have this task list be updated by a child component. To do that, you'll need to do it inside this parent component. And to do that, we're going to use an update task function. And unlike the delete and create, or I would state, sorry, I meant toggle complete functions, we're going to need to take a second value in addition to our ID argument. So we'll need to take the ID as an argument and then the actual, the name of the task. So task. So like before, we're going to set task list, and we'll take the previous tasks. So we're going to map over it again, take the previous task and check to see if it is indeed the task that we're, you know what, I just realized it might be a little unclear. So I'm just going to call this task value, because I realized task is also what we're using here. I think this should do it. Let's go and make sure to hook this up. And something is okay. It's up. Oh, okay. So what we did was it is updating. We just forgot to close this out. So to do that, we're going to have to wrap this in brackets and also put set is editing to, oh, do this. Cool. All right. So it looks like we've got pretty good functionality down. We're able to add tasks. We're able to delete it, and we're also able to update it. So yeah, it looks like we've implemented some pretty basic functionality to our app. But as you may have noticed, when we refresh it, it goes away, so nothing gets saved. So I think the next thing we're going to need to do is be able to implement some sort of way to persist this. And to do that, we're going to use local storage. And it'd be cool if we can also filter these tasks based off of whether or not they've been completed or not. Okay, so before implementing some of the other functionality, I'm going to go and clean up some of this code a little bit. So first thing I'm going to do is actually just put this task item into a different folder just to make sure things are a little more organized. Then I'm going to go and put this form in a different component. Oh, I just realized I had put this inside of the form, which I should not have done. Okay, so this is where that snippet I talked about earlier is going to come in handy. So instead of having to write the boilerplate code all over again, I'm just going to do RAFCE and just go and put that task form in here. Whoa, okay. We need to put this in a container, actually. Actually, we need to change this to Okay, cool. So now that we've tidied things up a bit, we can find some way to actually save our tasks so that when we refresh the page, we'll still have these tasks stored. So one way we could do that is with local storage. Typically, you'll be working with a database and that will save there. But since this is just a React app right now, we're just going to use local storage. So first thing we're going to do is we'll use useEffect to check to see if there are any tasks stored in local storage. So we'll do that. So what I'll do here is I'll just use a try catch block just in case the data might be corrupt. And then we'll also have to parse the tasks. So what we've essentially done right now is get tasks from local storage, and if it's there, set it in our task list. But we don't have a way to actually save these tasks just yet, so we're going to have to set up another useEffect for that. And what we're going to do is actually have our useEffect watch our task list, and essentially if task list changes, we're going to set that in our local storage. So and we'll make sure the dependency array is set up so that it watches task list. There, I think that should do it. So whenever we're updating task lists or deleting something, so anytime task list changes, whether we're toggling the completion status of it or deleting it or just creating a new task, it will update local storage. It'll update this tasks, I guess, in local storage. So let's go and test that out. It probably won't save because we haven't updated anything, so that looks about right. Let's mark it as complete. Okay, and it's still not working. Let's go and take a look at what is happening here. So clearly it's still being saved in the array. So we're going to have to check and see maybe when we're storing the item, let's see. And I'll also console log the stored tasks. So it looks like our tasks did indeed get fetched by local storage, but it looks like the tasks then get stored again as an empty array. And then it fetches from local storage and it's an empty array. And then it's stored again. So I think what's happening here is when we're rendering this app or this component, it does actually get the tasks that are saved. And then it sets it, or it calls the set. Okay, so I think I see what's happening here. So because when we're setting this task, it's happening asynchronously. it is setting it, but also what's happening is that we're setting local storage with an empty array, because when this component mounts, it's technically mounted as an empty array right here, which is why it's essentially storing it. So basically it renders, it fetches this stored task, and then it goes and runs. And so basically what it looks like is happening is when this component mounts, it does actually get the tasks item from local storage, but what also happens is this empty array gets set and it overwrites it, and then the component re-renders again, and basically it pulls the empty array that's been set from the previous render. So I think the way we're going to have to fix this is by creating some sort of guard to prevent it, so that basically we don't want to run this until we've actually set the task list. So I think what we could do is initialize another variable here and call it isSetting. And we'll initialize it as false. And we'll turn this into, we'll add this to the dependency array. So if either of this changes, then we'll go ahead and run this useEffect again. isSetting. Okay, so basically if the tasks are being set, so if it is setting, then we actually don't want to run this code. So we want to do if it is not setting, then we'll set local storage. And we'll delete this. And what we'll also need to do in here is that after this is set, we have to change isSetting to false. Set isSetting to false. And actually we need to change this to true. So actually what's happening is when we mount it, we need to set it as true first. So essentially what's happening now is isSetting is going to be true when we mount this, and once we get these tasks, once we get this task, we're going to set it and then also set isSetting to false. And then this won't run until isSetting becomes true or false. And this won't run until isSetting becomes false. So it'll only be false after we're done setting what's stored in local storage. Okay, so let's go and give this a try to see if it actually works now. Mark it complete. Okay, cool. It looks like it's working now. All right, so the next and I'd say final thing we have to do now is to create some sort of panel so that we could filter all of the tasks, whether they're completed or incomplete, or just to be able to view the full task list. So I think the way we're going to go about doing this is to create another piece of state for this, indicating what the filter is. So it'll be either all, I'll just add it. So we'll keep it as all to begin with, but something we could keep it. So some of the other filters we could add is all completed or active, but we'll keep all as the default state. Okay, so I think the first thing I want to do is build the filter buttons, or at least a control panel to have all of the filter buttons. So I'm going to put it right here under this this task form. I'll build it here, and then we could move it into another component. So it's likely going to be flex and have a gap of 4. Okay, so I think what I'm going to do now is create the active states for it, even though we haven't hooked up the functionality to these buttons just yet. Okay, now we actually have to hook up functionality to these buttons. So that actually should be pretty simple. We can actually just do this directly into the onClick. Okay, cool. Looks like these buttons do indeed update state. We'll go ahead and move this into another component file. Okay, so now that we've gotten a way to actually set the filter, we need to actually filter these tasks. And okay, so to actually filter this task list, there's a couple ways we could go about it. We could just filter it directly in here, but I think what I'm going to do is just create another variable for these filtered tasks. Awesome. So it looks like we've gotten the core functionality down for this app. The only little thing I would really add here is that, as you could see, if there's nothing here, it's just an empty block, which looks a bit ugly. So I guess what we could do is just conditionally render a message to tell the user that there is nothing here and that they would have to add a task. It would just be a slight UI change. So I think the way we could go about this is to check the length of these filtered tasks and to conditionally render a message depending on the length of filtered tasks. So what I can do is we'll just do let message equal an empty string, and if filtered dot length equals 0, and we'll render a slightly different message depending on what the filter is, right? So if filter and then what we'll need to do is just put a message in here. Looks good. Let's just make it so this message is looks a little better. Okay. All right, and there you have it. We have a fully functional task tracking app that is able to track our tasks. We're able to upload tasks, delete them, edit them, toggle them, and also filter them based off of their status. So obviously this is just a very entry-level sort of application, but it does use a lot of the core functionalities of React, and a lot of the principles do kind of build off of each other. So yeah, once you're a little more comfortable building these single page apps, building very nice and dynamic UIs, we're going to start building more full stack applications, because the truth is single page apps are kind of limited in what they can do. Obviously, we had to use local storage to store this. So in some of the upcoming lessons, I'm going to build more full stack focused apps where we're actually working with a database. That way we can actually build more functional apps and apps that people can hopefully be able to use. So keep an eye out for that, and thanks for watching.